Hi, hello everyone. So welcome to the channel. So in this video we are going to discuss straight lines of Junior Intermediate APTS states and NCERT class 11. So this is the basic chapter of the coordinate geometry, right? So this chapter is very important for the conceptual learning of the next upcoming chapters in the coordinate geometry. So we should have good basics regarding this particular chapter, straight lines, right? So if you are new to this channel, so please subscribe the channel and watch the video till the end. So don't skip the video and please share with your friends so that they also get benefited from this video, right? So let us get into the chapter, right? So the topics that we are going to discuss in this chapter, right? So the topics are inclination and the slope of a line. So we are going to discuss the straight line and the inclination and the slope of the given line. Next we are going to discuss about various forms of equation of a straight line. So how can we represent a straight line in different forms, and later on we are going to have the point of intersection of two lines. So when two lines intersect, then so what is their common solution? Next we are going to discuss about concurrent lines and the point of concurrency. Next, so with respect to a line, so what would be the image of a point? So regarding that we are going to discuss in our later videos. Next, angle between two lines. So when two lines are intersecting, then what is the angle that is formed between those two lines, right? So these are all the things that we are going to learn in this particular chapter, right? So in this particular video, so we are going to learn about the introduction of a straight line, right? So in that, first of all, we are going to talk about inclination of a line. So what is meant by inclination? So for suppose if this is my coordinate plane, so in a coordinate plane, so what do we have? So we have x-axis as well as y-axis, and their point of intersection is origin, and they will be perpendicular to each other. So this particular coordinate system is nothing but called as Cartesian coordinate system or rectangular coordinate system, right? So to the right side of the origin, so on the x-axis, so this we call it as positive x-axis, and to the left we call it as negative x-axis. Next, above the origin, so this particular vertical ray represents positive y-axis, and below the origin we are going to have negative y-axis, right? So first of all we are going to talk about inclination of a line. So for suppose if I draw a line, so this line cuts my x-axis at a particular point, right? So when it is meeting x-axis at a point, so it makes some angle with the positive direction of x-axis. If a line makes an angle theta with the positive direction of x-axis, so here we are going to consider this angle with respect to positive direction of x-axis in anti-clockwise direction. So if you consider an angle in anti-clockwise direction with the positive direction of x-axis, then such angle is nothing but called as inclination. So wherever it is formed, so the line wherever it is formed, so the angle should be taken from positive side of x-axis. So we need to consider from positive side of x-axis, that too in anti-clockwise direction, right? So this is, so let us consider this angle as alpha. Then this alpha is nothing but inclination of this particular line. Okay, now from this what we can simply say, inclination is nothing but angle made by the line with the positive direction of x-axis. So with the positive direction of x-axis in anti-clockwise direction, right? So if you observe any line, so that line will make angle from 0 degrees to 180 degrees only. So if you consider any line, so that line will make angle from 0 degrees to 180 degrees. So from this we can set the range of inclination. So the range of inclination is given from 0 degrees to 180 degrees. So it can be 0 degrees to 180 degrees, or sometimes we will be representing this as from 0 degrees, here 0 degrees to 180 degrees. So if you consider 0 degrees, then you should not consider 180 degrees. If you don't consider 0 degrees, then you can consider 180 degrees. So among these two ranges, any one of the ranges you can make use of, because so when you say 0 degrees, so 0 degrees is so whatever the line that is forming 0 degrees will also form 180 degrees. So both will represent the same line. So if both are representing the same line, no need of representing it twice. So that's why if you consider 0, you should not consider 180. If you don't consider 0, then you can consider 180 degrees, right? So from this clearly what I can say, a line can make angle from 0 degrees to 180 degrees, right? So this is nothing but inclination of a line. Next, to this inclination. So in this inclination, if I consider a horizontal line, so horizontal line means, so it makes an angle 0 degrees with the positive x-axis. So if I say a horizontal line, so what is the angle made by a horizontal line, or inclination of horizontal line is 0 degrees. The same way if I take a vertical line, so if I consider a vertical line, then the inclination made is 90 degrees. So these two values you need to remember. Okay, next moving on to the slope of a line. So what is meant by a slope? So already we have learnt about inclination, right? So for the inclination, if we apply tan, so if I apply tangent ratio, then it is called as slope of the given line. So slope of the given line is represented by the letter small m. So slope of a line is represented by the letter small m. So this slope is given by tangent of the given angle. So tangent of the inclination. So if I apply tangent to the, so tangent ratio to the inclination, it is nothing but we call it as slope of the given line, right? So from this what I can say, so if I am having a horizontal line, so if I consider a horizontal line, so what is the slope of horizontal line? So for horizontal line, slope is equal to, so already inclination is 0 degrees now. So what is tan 0 degrees? Tan 0 is equal to 0. So from this clearly slope of horizontal line is 0. The same way if I consider a vertical line, so if I consider a vertical line, then what is the slope? So m is equal to tan 90 degrees. So what is the value of tan 90 degrees? Tan 90 degrees is not defined. So clearly the slope of vertical line is not defined. So hence while solving the problem, so we will not be considering vertical lines. Since its slope is not defined, so we are not going to consider vertical lines to solve the problems. For suppose in any problem, if any vertical line comes, then we will be considering the slope as not defined. Okay, next one more thing. So if theta is given, then slope is given as m is equal to tan theta. Now from the trigonometry, so this theta value, so this, since this theta value ranges from 0 degrees to 180 degrees, no, from 0 degrees to 180 degrees. So if I can split this into two parts, so into two ranges, so that is nothing but 0 degrees to 90 degrees. So if I say from 0 degrees to 90 degrees, that means it is in quadrant number 1, and from 90 degrees to 180 degrees, so it belongs to quadrant number 2, right? Now in this particular ranges, so in first quadrant tan is positive, right? So in first quadrant tan is positive, so that means this is quadrant number 1, this belongs to quadrant number 2. So in quadrant number 1 tangent is positive, in quadrant number 2 tan is negative. So since in quadrant number 1 tan is positive, so clearly what I can say, slope is positive. So in first quadrant, that is nothing but from, for theta is equal, for theta 0 to 90 degrees, slope will be positive. So clearly what I can say, for m greater than 0, so if for suppose you get slope greater than 0, that means angle formed is acute angle. So the inclination is acute, whereas for 90 degrees to 180 degrees, the angle formed is obtuse angle. So from this what I can say, if obtuse angle is there, slope will be less than 0. If acute angle is there, slope will be greater than 0. So if and only if, so if inclination is acute, slope will be positive. If angle is, so inclination is obtuse, then m is less than 0. right? So from this some more points we can say those are slope of x-axis. So slope of x-axis. So here horizontal line doesn't mean that it is x-axis. So horizontal line is nothing but line parallel to x-axis you can consider. So slope of x-axis is nothing but the slope of horizontal line, so which is nothing but 0. In the same way slope of y-axis if I want, so slope of y-axis is not defined. So slope of y-axis is not defined. So clearly from this what I can say, slope of x-axis is 0, slope of y-axis is not defined, and slope from 0 to 90 degrees. So for 0 to 90 degrees slope is positive, for 90 to 180 degrees slope is negative. So I hope you have understood, right? So always theta is not given. So there is no, so always there is no situation that always the angle should be given, right? So in some situations, so 2 points might be given, right? So if 2 points are given, then how to find the slope? So when 2 points x1 y1 and x2 y2, so if these two are the points that are given to us, then how to find the slope? So from this slope m is equal to given as difference of y coordinates. So difference of y coordinates by difference of x coordinates. So this is given as difference of y coordinates by difference of x coordinates. So which can also be written as y2 minus y1 by x2 minus x1. So basically you can write like this, or y1 minus y2 by x1 minus x2. So this is nothing but the slope m is equal to y2 minus y1 by x2 minus x1, or y1 minus y2 by x1 minus x2. So this particular formula is applicable when 2 points are given. So when 2 points are given, then you can find out the slope by using this formula, or simply you can remember this. So difference of y coordinates by difference of x coordinates. You need to consider the same order. So if you are taking 2 minus 1, then denominator also you need to take 2 minus 1, or if you take 1 minus 2, then denominator also you need to take 1 minus 2, right? Next, moving on to one more. So for suppose the general form of line equation is ax plus by plus c is equal to 0. So general form of line equation is ax plus by plus c is equal to 0. Now from this, if he asks to find out slope, so the situations will appear like this, right? In the first situation what he has given, so when theta is given, how to find the slope? It is nothing but tan theta. Next, for suppose instead of angle, if points are given, so if x1 y1 and x2 y2 are the points that are lying on the line, if they are given, then how to find the slope? It is nothing but difference of y coordinates by difference of x coordinates. For suppose if line equation is given, if straight line equation is given, then how to find the slope? So the slope is nothing but given by minus of x coordinate, sorry, not x coordinate, it is coefficient. So it is simply given by minus x coefficient by y coefficient. So slope is given by minus x coefficient by y coefficient. So from this simply what I can say, it is nothing but minus a by b, minus a by b. So these all are nothing but the forms where, so whatever the conditions that are given, so based on that we are going to find out the slopes of the given situations, right? In the first situation, if theta is given, then we need to use tan theta formula to find out the slope. Next, for suppose if 2 points are given, then you need to use this formula, and if a line equation is given, then the formula is minus x coefficient by y coefficient, right? So from this equation, so what is the x coefficient here? Minus a by b. So this is nothing but my approach. Next, moving on to some more conditions, the conditions that we need to learn here, right? So next one is if 2 lines are parallel. So if 2 lines are parallel, then their slopes are equal. So what is the condition? If 2 lines are parallel, if 2 lines are parallel, then their slopes are equal. So this is most important point, then their slopes are equal. So this is the most important point we need to remember. So if you know a parallel line, then that parallel line slope will be equal to the next line. So for suppose if I consider x-axis, so this is my x-axis and this is my angle theta 1. So if this is the inclination made by my line, if I draw one more line parallel to this, that means if I consider this angle as theta 2. Now clearly what I am saying, these two lines are parallel, right? So if these two lines are parallel, then this line is acting as transversal. So when it is transversal, then we know that these corresponding angles are equal. So from this clearly what I can say, if lines are parallel, so for suppose this is line L1 and this is line L2. So what I am saying, L1 is parallel to L2. So if L1 is parallel to L2, then clearly theta 1 is equal to theta 2. Now what I can do, so theta 1 is equal to theta 2 on both sides. If I apply tan, then this becomes tan theta 1 is equal to tan theta 2. So from the formula, since we know m is equal to tan theta, right? So if I consider this as m1 and this as m2, so clearly what I can say, slope of first line equation is equal to slope of second line. So from this what I can conclude, if two lines are parallel, then their slopes are equal. So if two lines are parallel, then their slopes are equal. So if L1 is parallel to L2, then slope 1 is equal to slope of first line is equal to slope of second line. Next, if the same case, if I consider for perpendicular lines, so if two lines are perpendicular, so here the condition is, here two lines, so whatever the two lines we are considering, we need to consider them as non-vertical lines. So the condition is two non-vertical lines. If two non-vertical lines are perpendicular, then what we can say, product of slopes is equal to -1. Then their product of slopes is -1. So you need to remember this. Now from this what I am going to do is, so first of all I am going to consider x-axis, because here there is no use of y-axis, because inclination is made with x-axis only now. So that's why we are considering only x-axis, right? So don't misunderstand here. So y-axis will be there, but we are considering only x-axis, right? Now this is my one line, so let this angle be theta 1. So this inclination is theta 1, and for suppose this is my another line, so which is perpendicular to this line, because I said two non-vertical lines. So non-vertical line means, since if you consider non-vertical lines, their slopes are defined. Okay, so this is theta 1, and since they are perpendicular, this is theta 2. Next, if you want to take inclination, what we should take? So we should take from positive side of x-axis only, no? That means this angle is some theta 2. Now if you observe this figure, so this is nothing but a triangle, right? And in this triangle, this is external angle. So we know the property, external angle is equal to, that is nothing but exterior angle. So exterior angle is equal to sum of opposite two interior angles, right? So from this clearly what I can say, 90 plus theta 1. So theta 2 is equal to 90 plus theta 1. If I apply tan on both sides, so this becomes tan theta 2 is equal to tan of 90 plus theta 1. 90 plus theta 1. So tan of 90 plus theta, which quadrant? Second quadrant. In second quadrant tan is negative. Next, tan, because of 90, tan becomes cot. So this becomes cot theta 1. Again, how can I write cot theta 1 as? So this I can write as -1 by tan theta 1. Now from this, tan theta 2 means I can write it as m2, no? So m2 is equal to -1 by m1. So when I cross multiply, what I am going to get, m1 into m2 is equal to -1. So from this what I can simply say, the product of slopes, so product of slopes is -1. So did we get the same answer? So this is nothing but the result. So from this what I can say, if two lines are parallel, then simply their slopes are equal. If two non-vertical lines are perpendicular, then their product of slopes is -1. If for suppose if m1 is one of the slopes, then the slope of its perpendicular line is simply -1 by m1. So simply what we can do, just reciprocate it and keep a minus symbol in the numerator. Okay, So if you are having minus in the numerator, so it becomes positive value. So these are nothing but the points so related to slopes. Okay, next moving on to the different forms of lines. So different forms of lines. So before going to different forms of lines, so first of all we need to know what is a straight line. So first of all, what is the definition of a straight line? So a straight line is nothing but a curve. So straight line is a curve. So a straight line is a curve on which if you select any 2 points and if you join those 2 points by a line, so all the points of those lines should lie on that on the line completely. So then we call that particular line as, so that curve as a straight line, right? So straight line is nothing but a curve on which if you select any 2 points and if you join them by a line, so all the points should lie on the given curve. Such a curve is called as a straight line, right? Now in this thing, so we need to understand some points. So what is that? So if you want to represent a straight line uniquely, see, for suppose if I am given with an angle, so for suppose if I am given inclination theta, then if you are asked to draw a line, so you will be drawing a line like this, right? Or so some other person will be drawing the line like this, because what he has given, what you are given with, so you are given with only the inclination. So with inclination alone, so we can draw infinite lines, because so you are not defining it in a unique way. Understood? So with single entity or with a single thing, you cannot draw or represent a straight line uniquely. So to represent a straight line in an unique way, so always you need to have minimum 2 quantities that are known, or simply what we can say, we need to know 2 entities. So those entities may be slope, points, intercepts, right? So these all are nothing but the entities. So if you know minimum 2 entities, then we can represent a straight line in a unique way, right? So based on the things that we know, so we are going to represent a line in different forms, right? So you have understood so what is a straight line, right? Next moving on to, so the general form of a straight line, so we are giving as, so ax plus by plus c is equal to 0, where a not equal to 0 or b not equal to 0. So at a time both should not be equal to 0. So either a can be 0 or b can be 0, but at a time a and b should not be 0, right? Now we are going to have the various forms of lines. So various forms of straight lines. So among those various forms, the first form is slope form, or this is also called as gradient form. So these forms are very, very important. First one is slope form or gradient form. So if you can understand these forms, then you can solve any problem in an easy way, right? So first, a slope form. So what is meant by slope form? So slope form means the particular line will pass through a point 0, 0 and its slope is m. That means here how many entities are given? 2 entities are given, right? So what are those 2 entities? One is origin. So that means slope form is nothing but a line which passes through origin and having slope m. So if these 2 entities are given, then we can represent a straight line. So for suppose this is my straight line, so which is passing through origin. So this is my x-axis and this is my y-axis. So it is not, so its slope is m and it is making some angle theta, because since we know the slope, so we can find out theta. Next it is passing through this point 0, 0. Now for suppose consider any point P. some x comma y, which is the locus of this straight line. So P is nothing but a point x comma y, which is the locus of this straight line. Okay, now since we know slope, right? So slope is given by m is equal to, since we know 2 points, so one is point 0 comma 0 and the other point of locus is x comma y. So from this we can apply slope formula, no? So what is slope formula? M is equal to y2 minus y1 by x2 minus x1. So from this clearly what I can say, y minus 0 by x minus 0. So from this what I am going to get, m is equal to y by x. So clearly from this y is equal to, I can write it as mx. Y is equal to m into x. So this is nothing but we call it as gradient form or slope form. We call this form as gradient form or slope form. Y is equal to m into x. So here you don't have any constant term. So from this what you can understand, when a line is passing through origin, it will not have any constant term. Okay, so this is the first form, so which we have, slope form or gradient form. Next, moving on to the second form. So second form is nothing but, it is called as slope intercept form. So the name itself suggests slope intercept form. Slope intercept form. So here two entities are given, one is slope and the other one is intercept. One is slope and the other one is intercept. So if these two things are given, then how to represent the straight line? So here there are two possibilities. So this intercept can be x intercept or y intercept. So there are two possibilities for this intercept. So first of all we are going to consider y intercept. Now what is meant by intercept? So that we need to have an idea, right? Now this is my x axis and y axis. Okay, now when I draw a line, so this line intersects x axis as well as y axis. It intersects x axis and as well as y axis at two distinct points. Now for suppose if I am going to consider y intercept first. So y intercept means, so from the origin where my line cuts y axis, this particular distance is nothing but called as y intercept. Understood? So y intercept means from the origin where my line cuts y axis, is that distance is particularly called as y intercept. Okay, here y intercept I am going to consider it as some value c. That means this point is 0 comma c, because on y axis x coordinate is 0. So this point is 0 comma c. Now since this line is having slope m, this line is having slope m, and let us consider a point P x comma y such that it is the locus of this straight line. Then from this, using the slope formula, m is equal to x minus, difference of y coordinates, no? So slope formula is y2 minus y1 by x2 minus x1. So clearly what I can say, so y minus c by x minus 0. So on cross multiplication what I am going to get, mx is equal to y minus c. So from this y is equal to mx plus c. Y is equal to mx plus c. So this is nothing but my slope intercept form when y intercept is given. So this y intercept is c. So from gradient form, so this is somewhat different. So plus c is added here. So to the gradient form, if plus c is added, then we are going to have slope intercept form, and gradient form is different from slope intercept form, right? Here constant we are getting, right? If the situation changes like this, for suppose instead of y intercept, if he has given x intercept, so x intercept means you can easily understand from origin to this point of intersection of my line with the x axis. So this distance is nothing but I call it as x intercept. So for suppose if x intercept is equal to some a, if x intercept is equal to some a, that means this point becomes a comma 0 only, no? Because on x axis y coordinate is 0. So clearly, so this is nothing but point of locus and this is my point. So by applying slope formula, so m is equal to what I can say, so y minus 0 by x minus a. So from this, what is the value of y? Y is equal to m into x minus a. So this is nothing but my slope intercept form. So here I am having slope as well as intercept. Okay, clear? So this is nothing but slope intercept form, so which is nothing but the second form. When you are given with a slope as well as intercept, then you are going to have these formulas. So first one is y is equal to mx plus c, where c is y-intercept and m is the slope, and the second form is y is equal to m into x minus a, where m is slope and a is x-intercept. So remember this slope intercept form, right? Next, moving on to the third form. So form number 3. So third one is point slope form. What is this? Point slope form. So point slope form. So name itself suggests, so there is a point given x1 comma y1 and the slope is given m. So from the name itself, so we are going to have the form, right? So if a point is given and a slope is given, so clearly, so from the diagram, so how can I represent this as, so there is a line which is passing through a point x1 comma y1 and this is having slope m, and the locus of point P x comma y, I need to find it out. So from this, clearly using the slope formula, m is equal to y minus y1 by x minus x1. So when I cross multiply, so what I am going to get, mx minus mx1 is equal to y minus y1, right? So from this, what I can write, so m is equal to y minus y1 by x minus x1. So from this, clearly how can I represent this as, so I can directly write it as mx plus y is equal to mx1 minus y1, right? So this is nothing but my point form, or what we can simply say, otherwise you can represent this as y minus y1 is equal to m into x minus x1. So this is nothing but my general representation of point slope form. So when point and slope are given, then this is the formula that you need to apply. So y minus y1 is equal to m into x minus x1. Next, moving on to the fourth form. So the fourth form is when 2 points are given, which we call it as 2-point form. So 2-point form means, so here you will be given with the 2 points x1 comma y1 and x2 comma y2. So here you are not given with the slope, but still you are having 2 entities. Then from this, what I can say, so already you know the formula for slope, right? Now from this, already you know point slope form, so which is nothing but y minus y1 is equal to m into x minus x1, right? M into x minus x1. So instead of this m, since 2 points are given, so we can apply the slope formula using 2 points. So from this, what I can write it as, so y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1, right? Understood? So from point slope form, you are having this equation. So already we know when 2 points are given, we can write the slope using those 2 points as y2 minus y1 by x2 minus x1. So using this condition, so if I move on the variables of y and x on to one side, then I can write it as y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So you can observe the symmetry here, right? So y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So this particular form is nothing but we call it as 2-point form. So here 2-point form. So how will be the figure? So you will be having 2 points x1 y1 and x2 y2, and if we want, and we need to find out the locus of point P x comma y. So for that we are going to get this particular equation, right? So this is form number 4. Right. Next, moving on to form number 5. So form number 5 is nothing but intercept form. Intercept form. So what is meant by intercept form? Here both the intercepts are given. So we are given with both the intercepts, x intercept as well as y intercept. Whereas in form number 2, what we have slope and one intercept, not both the intercepts, right? So here we are having both the intercepts, so hence we call it as intercept form. So what is intercept form? So we are going to have x axis as well as y axis, and my line cuts x and y axis at 2 points, right? For suppose if this distance is a and this distance is b. So always don't think that my line cuts like this only. So it may change its direction. So sometimes it may cut like this, or it may cut in the 3rd quadrant, or it may cut in 4th quadrant also. For our convenience to explain one example, so what we are doing, so we are considering in 1st quadrant, right? So if this distance is a, so this distance is nothing but we call it as x intercept, and this distance we call it as y intercept, right? So if this is x intercept, then this point is represented as a comma 0, and this point is represented as 0 comma b, right? So based on these length of intercepts, so we are going to have these points. So when you know 2 points, and for suppose this is the point of locus p x comma y, then using this condition, so we can directly go with the equation. So what is the equation? So already we have written, right? So what is that? So when 2 points are given, so these are nothing but 2 points only, no? So when 2 points are given, what is the formula? X minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1. So just now we have discussed, right? So this is y1. Now when I substitute the values, x minus x1 is a by x2 minus x1. So x2 minus x1 is 0 minus a is equal to y minus y1. So y1 is 0 by y2 minus y1, so which is nothing but b minus 0. So from this what I am going to get? X minus a by minus a is equal to y by b. So when I do cross multiplication, or simply how can I write this as minus x by a, this becomes minus a by minus a, which is nothing but plus 1, is equal to y by b. So when I transpose this minus x by a, this becomes x by a plus y by b is equal to 1. X by a plus y by b is equal to 1. So this is nothing but my intercept form. X by a plus y by b is equal to 1, where a is x intercept, b is y intercept. So here a is x intercept, b is y intercept. So b is equal to y intercept. So when intercepts are given, so we can make use of intercept form, right? So using these 5 forms, so we are going to have the problems related to the first exercise of our textbook, right? So we are going to discuss those problems in our next video. So thank you for watching the video, and a lot more is to come. So stay connected with the channel, and please subscribe the channel, and please try to watch the videos till the end. And if you like the explanation, so please share with your friends so that they also get benefited from this video. So thank you for watching the video.